Read the question, no? The point of suspension, the minimum velocity that much imparted into the bob at lowest point to complete vertical circular path is. Did the bob, okay, previous case, point of suspension moving. Now what about here? The point of suspension is accelerating. So what is the basic idea? Critical point you have to identify, and next at critical point, if the bob is having critical velocity, it will complete the circular path. And to get the minimum velocity, what happens? You should apply between the initial point of projection to the critical point. What all that energy relationship. So what is the total idea of the problem? Identify critical point in the situation. After getting critical point, identify critical velocity. If the bob is having critical velocity at critical point, it will complete the circular path. And what velocity should impart at the lowest point so that at critical point it should have the critical velocity. Then the velocity of what we impart the velocity at the lowest point, that will be minimum. This is one idea what we have discussed in the previous class. So that has to be applied here now. I'll give 2 minutes time, just think over it. Huh? Okay, how to, shall we calculate the velocity at highest point? What do you mean by critical point? The tension should be minimum. So you have to identify the situation where the tension can be zero and the resultant of forces can provide required centripetal force. I think that's what we have to search it. No? So if you look at the total circle, yes, yeah. So look at the total this one. So let it be this is a bob. So this is a string. Okay, let's try to search critical point. What we have to do? In fact, this is accelerating. This is accelerating. The point of suspension is accelerating. Then, so try to look at the various positions. So various position means let me go for directly higher point. So it's a trial and error now. Now there nothing is there, so you have to you have to go back to the various points. So what are the various points? These are the possible regions, no, where we have to search like this. So here is what I locate the bob, or if you want, you can choose this also. Altogether, 8 possible things are there, no? At 8 possible things, try to verify where tension can be minimum. And what is that black dot? There is a bob. There is a bob. No. Now, first thing, so we'll start at point 1. At point 1, T1, this is mg, and pseudo force will act like this. What about here? T2, mg, and pseudo force. Pseudo force, mg, and T3. I'm just, see, we have to analyze things, huh? Then I can get into the thing there. So here what happened? The pseudo force, ma naught, mg, and T5. ma naught, mg, and tension T6. So this will be ma naught, tension T6. This will be T7, ma naught, mg. T8 and mg, where the critical point can arise. And at several points, it will have velocity. So how the velocity here, you can write it. We have imparted velocity u, no? Here it will have v2, v3, v4. Now with respect to which frame we are discussing, with respect to O, v6, v7, v8. Now, what is the basic idea of the critical point? It's a point where the tension will be minimum. What is the lowest value of tension you can take it? Equal to 0. So even if the tension is minimum, still what will happen? The other forces should provide required centripetal force. Then only it's possible, no? So can critical point, can it be at 1? Can it be at 1? I think I just indicated tension. So from tension only, I'm saying 0.192. So can it be at 0.1? No, it's not possible, no, here. So what about T2? I think the resultant of the tension here will be maximum. You check it in this particular thing. So here also. So compared to all, where tension can be minimum, the tension can be minimum at 6. Because even tension 0 here, so tension can be 0 here. Let's come. Tension at 2, so if it is 0, will provide required centripetal force. Nobody is there. Here at 3, 0. Nobody is there. What about here? So component of mg and ma naught. Component of mg and ma naught. So tension can be 0. Okay, this is a 1 point. Okay, we'll see 4. Here, if tension 0, mg will provide required centripetal force. So why can't we take this one? Look at this particular thing. Look at 6. Component of ma naught and mg will provide required centripetal force. Then what about here? Tension 0 also, ma naught will provide. And look at this particular point, ma naught, say some component of ma naught and mg sine theta can provide required centripetal force here. So among all, okay, why only one specific point only we are picking up that one. So what do you mean the critical velocity? Critical, no? The speed of the bomb will be least. So where it can be least now? At 6 only. We'll agree that the speed of the bomb will be least at 6 only. Able to get this? So no. So he's asking to get that particular thing. So we can do one thing, sir. How do you can? There what will happen? The resultant of all forces will be acting towards center and tension can be tension can be 0 also. For that purpose, what happen? We'll do one thing. We'll take a situation. So we'll take a situation. We'll find out. We'll even get the angle also. The angle at which the tension, what happen, will be minimum. Also there, what will happen? The speed, what minimum speed you can project here. So first of all, any condition for tangential acceleration at critical point need not be 0. Most of the problems it is 0. At critical point, tangential acceleration need not be equal to 0. So you write down the equation T6 plus, okay, let me take this is theta. If this is theta, this will be theta. Then this will be theta. I'll draw a circle only with respect to okay, this is the bob. We have given velocity at the lowest point. Here it will have velocity v. And how pseudo force will act towards left. Let me show all forces acting. Ma naught. So here the pseudo force ma naught, and let this be mg. Let this be theta. Let this be theta. Tangential. Let this be theta. So here let the t be the tension. So write down the equation for the equation of motion at this particular point P, or critical point you can call this one. Critical point Cp, you write it. So here the equations of motion will be T plus mg cos theta plus ma naught sin theta equal to mv square L. Okay, got this one. So now here select mg cos theta, ma naught sin theta, all they are constant, no? So the tension, the V will be minimum if T is minimum. What is the lowest value of T? You can suggest, propose here, T equal to 0. So when T tends to 0, V tends to V minimum. So this will be mg cos theta plus ma naught sin theta equal to mv square by L. So this is the one equation. You can keep it, or V square equal to m will get cancelled. We'll get expression for V. Now what I do is, I'll apply Work-Ng theorem from the lowest point to that critical point here. So this should be the Work-Ng theorem, should be initial kinetic energy, work done by the gravity. So as this is theta, this will be L cos theta, and this is L. So work done by the gravity will be mg L plus L cos theta. Minus work done by the pseudo force when it moves from lowest point to the critical point. So how the pseudo force is acting? Pseudo force will act towards left. So what is the net displacement? Will be L sin theta. So work done by pseudo force will be L sin theta. This should be equal to mv square by 2. So u square minus 2gl 1 plus cos theta minus 2a naught L. I'll answer. Let me finish off the problem. So substitute the value of v square from here. So our other equation will be g cos theta plus a naught sin theta gl. The above equation, let me simplify it. gl a naught L sin theta equal to v square. Call equation 1. Call this is equation 2. Now substitute value of 1 in 2, and you'll get u as a function of theta. Then we'll differentiate. because minimum velocity, what I should project here. Then I'll get in a specific relation between A naught and G. This is the acceleration, A naught is there. So substituting, put 2 in 1 or put 1 in 2. U square 2GL 1 plus cos theta minus 2A naught L sin theta. V square will be GL cos theta plus A naught L sin theta. Equating this, U square is equal to minus 2GL, so this will be 2GL plus 3GL cos theta minus 3A naught L sin theta. So what is value of U? U should be
So plus 3
plus 3A naught L. Okay, now let me 2GL 3GL cos theta plus 3 naught AL sin theta. This will differentiate. So du by dt. So this will become 1 by 2. So 2GL plus 3GL cos theta plus 3A naught L sin theta. Differentiation of this will be again this quantity. If you differentiate, 2GL is a constant, so minus 3GL sin theta plus 3A naught L cos theta. Let it be equal to 0. So finally what we are getting, A naught equal to G tan theta. Or what should be the tan theta? I think we have to search for the angle, no? Tan theta equal to A naught by G. So where the, and what is this theta? Theta is what I got, that one. Tan theta equal to A naught by G. So I got this angle where it will be a critical point. Okay, substituting this value of tan theta equal to A naught by G, no? Sin theta, cos theta you replace, solve for it. You will get expression for the minimum velocity of projection. Okay, next question comes like, okay, this tan theta, theta equal to A naught by G. Let me come back. Okay, write the equation of circular motion. At every point you write it. At every point you write it. At every point you write it. Write like how I wrote equation for circular motion, no? And make t 0 and check the velocity. And check the velocity. So definitely what happens, theta equal to. So here how much it is? So what is saying, theta equal to tan inverse of A naught by G. When the string makes an angle, what theta? Theta I define like this. With respect to vertical is what we have defined it. Now look at that at critical point. Again, at critical point. So I think we'll first calculate the sin theta, cos theta value. Okay, can you work out further? So this is theta. Tan theta is A naught by G. So this will be A naught square plus G square. So sin theta will be A naught by let me define that sin theta also from here. Sin theta equal to A naught by root of A naught square by G square. So what is cos theta equal to G by root of A naught square plus G square. So substitute that, we'll get U minimum equal to 2GL GL 2 plus 3. Cos theta will be G by root of A naught square plus G square. So only G will not be there. Plus 3 A naught L cos sine theta will be A naught by root of A naught square plus G square. Okay, this will be the minimum velocity. Okay, now write equations of motion at all the points. Write equations of motion at all the points. So what is the basic necessity condition? Where the tension is minimum and tension can be zero, where the resultant of other forces can provide required centripetal force, then you can call that as critical point here. Oh, no, 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 no. When the bob moves from here to here, what is the net displacement? Is only L sine theta, no? The bob has moved from here to here. So work done by pseudo force will be only this L sine theta. Okay, Lokesh. Huh? Fine. Look at the diagram. Displacement from lowest point to critical point is L sine theta, horizontal displacement. So work done by pseudo force should be minus L sine theta, minus MA naught L sine theta. Gravity acts opposite to, as it moves from lowest to highest point, the gravity will act vertically down, displacement up. Okay, all these two will be negative, no? Next, again at critical point, what is the condition? At critical point, A tangential. So I think this information is least in the books. It's not available much. At critical point, what is the necessity conditions? Tension tends to zero. Critical velocity, V will be minimum. And what about A tangential? A tangential may be non-zero, you have to put it. And it's not necessary condition, it must be equal to zero. When it be zero, put A naught equal to G. If A naught equal to G, then the tangential acceleration becomes zero. If A naught is not equal to G, then what happens? The tangential acceleration become non-zero. So therefore, at critical point, tangential acceleration must be zero. Need not. These are the some conceptual things they'll ask you. Unless you don't discuss such numericals, not possible.
Sir,
Okay, you do one thing, write equation at 0.45, everything, check the equation, check the velocity, check the velocity at that particular point, and check the U minimum, check the like a V critical velocity, all that one, check it all. So definitely you can see that at 6 only what will happen, it will be least. You have to write down everywhere the equations.
Sir,
So what is the best way of analyzing this problem where the resultant of the forces are acting towards the center, there the tension can be minimum. Will I agree? The simplest idea from circular motion, from the circular motion concept where the resultant of forces are acting towards center, there the tension will be minimum. So you can see the resultant of forces will act here. So the tension at 6 will be minimum here.
sir, can you tell how tan theta is A naught by?
Okay, from mathematics, du by d theta. Differentiating.
sir, sir, here if we differentiate, we also will get it right, sir, because it's V minimum.
No, directly I'm going for u minimum. No, what minimum velocity I should project it. So directly I'm calculating that. So what to I got something theta equal to this much of relationship. Okay, now you calculate the critical velocity there. So what should be the critical velocity? So now you can go and substitute that one. You'll get the critical velocity. Straight away, there's a mathematical approach you can bring it. Or what is the physics idea? The resultant of forces should act towards center. So at 6, what happened? The resultant of forces can act towards center. MA naught and MG both are acting towards center. There the tension will be minimum.
Sir, how displacement of A naught you took as L sin theta?
L sin theta only. So it moves from here to here. When it moves from here to here, what is the displacement? Only L sin theta, no? It's over, no? Yeah. When it moves from here to here, what is the displacement? L sin theta only. Fine.
Sir, will you once explain why du by d theta is 0, sir?
For minimum, no. To minimize. To minimize. Because he's asking minimum velocity, no? Find the minimum velocity that should be imparted to the bob at the lowest point. To check the minimum, what happen? I can differentiate, no? And equate to 0. Already forgot?
Okay, sir, understood.
Okay, now a constant, I'll describe the question. So next